So we are on Unit 7, Day 5 notes. Here are our objectives for this day of notes. I cannot stress to you enough that this stuff takes practice. Alex will help you with that. A lot of times, if you need that extra push, if you need that extra teacher aspect of it, of course, I am always available for my office hours. Please check your syllabus, check your announcements. I'm available that way. Not many times, not only during my office hours, but outside of my office hours sometimes, depending. But please, you do the work. That's what helps you to understand these problems. These problems are not simple. This is going to be a long haul, but we're going to get through it together. Okay. So, um, let's start with the first start problem. With these type of problems, they look much more difficult than they are. Knowing your rules for dividing and multiplying are very key and essential here. What you're going to do here, the 6 is up top. You're dividing the 6 by the fraction here. You can put this in your calculator, but the reason why I'm not going to is because it's just the understand processes. So because when you get down here and you can't put them in your calculator, you'll kind of know what to do. So I'm going to take the 6, and of course we're dividing that by 5/3. Okay. Since these are all numbers, you could technically put them in your calculator, but to understand process, what you're going to do when you're dividing a fraction is you're going to take the first number, keep it the same, multiply by the reciprocal. That means you flip this fraction and put 3/5. Multiply by 3/5 at the top. So this, if you do that, remember that if it's a whole number, if you put it over 1, you have to multiply the top straight over the bottom straight. 6 times 3 is 18. 1 times 5 is 5. 18/5. Let's see if our calculator would give us that same answer. So if we had 6 divided by, maybe it'd be help if I turn it on. 6 divided by 5/3, so 5. I'm going to make it like this, 3, okay, my backwards L3. And then that's what you get, but then if you push second, AB, backwards L, it'll give you 18/5. So it does do that. It gives us our answer in fraction, but when it became a mixed number, I pushed second and then that AB again, that's the number right over, the little button right over sign, and it gave me 18/5. Okay, so we did get that. Again, same situation, you keep the top 8/9 the same. You're dividing 5/6. Sometimes it's easier to look at it like how it's this instead of putting this division. So when you get an answer, all you have to do is keep that the same, multiply by the reciprocal. Okay, so I flipped that and made it 6/5. So you can cross simplify. Okay, and that's what you're going to be doing down here, simplifying. So if I simplify this, I divide it by 3, it becomes 3. Divide this by 3, it's 2. Can't simplify here, can't simplify here, can't simplify here. Multiply straight across, that would be 16/15. Okay, and again, if I put that in my calculator, let's see, 8. Then I put the little backwards L9, divided by 5, backwards L6, which is basically backwards 6. Push enter, and then I'll push second, little ABC, and then it'll be 16/15, just like what we got there. Okay. All right, let's move down to some of these more difficult looking problems. And yes, they get more and more progressively difficult during this these notes today. I mean, we're going to get into really, really weird looking stuff, and hopefully I make it clear for you. And if not, again, that working in Alex, understanding that sometimes in mathematics, seeing it for the first time and the second time sometimes is stressful, and it's like what. But the more you see it, the better you get at it, and the more you get kind of used to it. And that's the difference. Everything is definitely not as soon as you see it, I'm going to understand it. No, it just does not work like that. Okay. For some people do. Okay. So this is the same situation that we just dealt with. So we have 5c to the fourth, b to the fourth. over 28b to the fifth. We're dividing that by 10c squared d over 7ab squared. Okay, so now, same thing we just did. We are going to leave this the same and multiply by the reciprocal, 7ab squared over 10c squared d. We can cross simplify. 28 and 7 become 4. Okay, a, there's no a here, but b to the fifth and b to the second, it kind of subtracts, so b to the third is what's left here. The 5 and the 10, that becomes 2. C to the fourth and c squared, this now becomes c squared because we subtracted 2 from it. D, this will become d cubed, and this d is canceling out. Doesn't look like we can do anything else. What's left over here looks like a, I see a C, a D, okay. So what's left over there is going to be a C squared D cubed. Okay, so all of those are done. Then I have 4B, 4 and 2. 4 times 2 is 8, so it's going to be 8B cubed is what's left over there. That's my answer. Okay, so all the leftover I kind of put together in one situation. Okay. All right, so it's not as bad as it looks. It looks difficult, but it is just understanding processes. So again, I'd write this out, 5mn squared over 14x squared y divided by, see, sometimes it's easier for me to write it like that as opposed to like this type of division, although this is still division. 20n to the fourth over 7x cubed y cubed. So I keep the first the same, multiply by the reciprocal here, 7x cubed y cubed over 20n to the fourth. I would cross simplify. 14 and 7, this becomes 2. X squared, x cubed, there looks like there's 2 there, 3, only 1 is left over when I subtract those. Here, y squared is left over there because there's 3 here and there's only 1 there. 5 and 20, this becomes 4. M, no m's there, but they have an n squared, this becomes n squared because the 2 there we're subtracting. What's left over here looks like m x y squared, so we have m x y. Why do I keep breaking these pencils? Y squared. And then here it looks like 2 and 4 is 8. And then no x's, no y's, n squared. N squared. That's my answer. Okay. So again, of course, they start off kind of canceling stuff out, making it a little bit simple for you, and then here we go. Gets a little bit more crazier. Once we get to the next page, it's like full out craziness. Okay, same situation. I'm going to write it out so that I feel comfortable kind of with it. Okay, I can digest it a little bit better. U squared minus 6u plus 9 all over u minus 2. I am going to factor that. So if I factor that, I know that it'll be same, u minus, okay, multiples of 9, that's subtracted, add to give me 6, both of them are going to be negative. 9 is 3 and 3, okay, so that's kind of what that one becomes. So when I have to flip it, I'll have u minus 3 over u, that stays the same, times u minus 2 at the top here, and that u minus 3 at the bottom, okay? So what cancels out looks like the u minus 3. So what will be left over is u minus 2 over u times u minus 3. We know we have some type of, u cannot be 0, u cannot be positive 3. Those are exclusions. You do not have to do that right there, but it's good to know that, okay? Everything kind of goes together, all right? Let's move down here for our next STAR problem, okay? Same situation. I like to put it so that I can kind of see it. If by now you don't really have to do that, it's okay with me if you don't. Of course, do whatever makes you feel good. Again, for teaching purposes, I'm definitely going to try to write it out. Okay, I factor that. It becomes same, both negative, and it looks like 7 and 7, because 7 times 7, but 7 plus 7 is 14. Okay, so that's what this becomes. So now it becomes b minus 7 over 2. I'm leaving that the same, times the reciprocal, b plus 2 over b minus 7, b minus 7. Okay, cancels out there. This becomes b plus 2 over 2 times b minus 7. Okay, if we had to do some exclusions there, positive 7 would be that exclusion. Cannot have positive 7 there, but this is our answer. Okay, let's move over here. This is really, really the same situation. Okay, w squared plus 9w plus 20, and they want to give you a lot of little examples so that you're getting that practice, divided by w plus 4 over 3w. Okay, here, same multiples of 20 is or 4 and 5, so w plus 4, w plus 5. Okay, that's what that would be. Of course, that's like a lot of aggression or something, because I'm like, these pencils are breaking. All right, so now this would stay the same, w plus 4 over w plus 5 over 2w squared. Multiply by the reciprocal here. 3w would go top, w plus 4 would go at the bottom. So I see that the w 4's cancel out. There's a w here, 2 squared there, and a w there. This just now becomes just regular w. Anything else canceled? No. So this becomes 3 times w plus 5 all over 2w. 2w. So looks like, yep. Good. So that is my answer here. Okay. All right, let's go to the next page, which this page is where the good fun starts. Okay, this is very, 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 when you look at it, you're like, what is even going on here? Okay, so we are going to get into this. It's going to be fun. We got this. We're going to do this well. All right, so first and foremost, I'm looking at these two situations like they're two different situations at first. And then once I get through those situations, then I can deal with them as an entire problem. So for the top, I need to have some type of common denominator. And if you really look at this, what this is basically is this x minus 9 plus 3 over 1, okay? So that particular situation, what is the common denominator? X minus 9. So if I had to change that, it would be x minus 9 is the common denominator, plus, of course, over here it has to be x minus 9 as well. That's the common denominator. So here I didn't add anything, so the top stays the same. But if you see here, this was 1, now it's x minus 9. So I added the x minus 9, so I have to add the x minus 9 here. Okay, so I'm just using, I'm solving this problem like it's its own problem. Okay, so let's kind of do the same thing at the bottom. If you see that, it's going to be 15 over x minus 9 plus 5 over 1. Now, if I made the common denominator x minus 9, okay, then this would stay the same at the top. Why? Because it didn't change. But here, instead of 1, it became x minus 9. So now, basically, that's adding that x minus 9. So this becomes 5 and then x minus 9. Minus 9, sorry. Okay. Let's distribute that there. So this, okay, so this 9 over, you got to keep stuff together, x minus 9. And see, being, having handwriting that's legible is important in this situation, because if you don't know what you are doing or what you put or where things are, then you're going to struggle. This now becomes plus 3x minus 9, and we can put those together. Why can we put them together? Because remember how we did this, it's a common denominator now. Now we can put 9 plus what, 3x minus 27 together, all over x minus 9. okay, over, same thing here. These are now have common denominators. We're going to distribute that, but it becomes x minus 9 is at the bottom, but this becomes 15 plus 5x minus 45, looks like. Okay. Combining terms, 3x minus, 27, negative 27 plus 9 is negative 18 over x minus 9 divided by, what's that? Negative 45 plus 15 is going to give you negative 30. So this becomes 5x minus 30 all over x minus 9. Okay. There's multiple ways you can handle this part now that you have it here, but I would do this. I can take out this 3, and this becomes x minus 6 over x minus 9 divided by, because of course I'm dividing it by this, this becomes 5 times x minus 6 over x minus 9, okay? So I just put this beside it, but I still factored it. Okay, I factored this top, and I put it up here, and I factored this, I put it here, I'm dividing. You know from what we've just been doing that this is really going to be, stay the same here, multiply by the reciprocal, okay, there. Okay, I flipped that. So now these cancel out, these cancel out. Your answer here looks like it's going to be 3 over 5. Look at all of that work for that one problem. But understanding processes is important. Going through, being patient, taking your time, you got this, okay? So it wasn't anything like crazy, crazy math, but it was just long and a lot of processes. Same situation happens here. Let's get that top together first. What is the greatest common factor? What's the LCD there? 2x, okay? So we know that with 2x here, what did you add? You added x. So you know you're going to multiply this times x too. So this becomes 3x. And then here you added 2. You multiplied by 2 to give you that. So this becomes 2. That's 6. So up top, what happens when you get the common denominator of 2x, you get 3x plus 6 up top there. Okay? Now let's do this part. What is the common factor? What's the greatest common factor? It looks like 4 and, yeah, 4x squared. So 4x squared is the common. 4x squared is the common here. If you wanted to do that, you know this is 2 times 2, and that's a 2. Okay? And that's, of course, is a 2. You see how 2 is common there? You would write it once, but then that extra you'd have to put it. That's why 2 times 2 became 4. That's the common for that. And then the x squared, you take the highest for the greatest common factor. I mean, LCD, least common denominator. All right, so we have 4x squared is our least common denominator. What did I add? I added, it looks like from here to here, I added that. I'm going to take this down because we need all this space. Okay, I added an x. So here I have to multiply the x up top. This becomes 9x. What did I add here? It looks like just multiplied by 2. So I have to multiply the top by 2. That becomes 18. So when I get over here, it becomes 9x plus 18 over 4x squared. Okay. If you want to take something out there, you can. That looks like a 3 comes out, and this becomes x plus 2 all over 2x divided by, I'm taking 9 out here, x plus 2 over 4x squared. And if I had to multiply them, which I do, 3 and then x plus 2 over 2x times the reciprocal, 4x squared over 9 times x plus 2. Again, the 2 looks like it cancels out there to make that 2. This one cancels out. That just becomes an x. These 2 cancel out. Look at the 9 and 3. 9 and 3 cancel a little bit. Simplify. So now straight across, that becomes 2x over 3. okay, because that's what's left over. Because I'm simplifying, cross simplifying. Got it? Sorry about that. All right, so let's move on. That I'm sure some of you watching this thought that was your phone. Every time I watch a video and the phone goes off, I think it's mine. All right, so same situation happens here. Common denominators. Remember, that's over 1. That's over 1. The common denominator there is pretty simple because it's over 1. So it's going to be just 4x and 4x there. Okay, so we didn't change anything there, but here you have to multiply by 4x. So you have to multiply the top by 4x. So the top 3x, 3 times 4x is 12x. All right, bottom common denominator is 8x. Okay, you didn't change anything here, so that one stays the same. But this, if you multiply this by 8x, you have to multiply top by 8x. So this becomes 8x over 8x. Here, let's combine like terms. 12x, over here. 12x plus 5 over 4x over, looks like 8x minus 1 over 8x. Okay, if you want to put them side by side, you can. We don't have to at this point. We've done it enough. X plus 5 over 4x times now the reciprocal of the bottom. 8x over 8x minus 1. Okay, so now let's, is there anything we can't simplify there? Can't simplify there, but we can, looks like we can simplify this way. So the x's cancel out. 4 and 8, okay, 4 into 8 becomes 2. So now let's say 2, we're going to multiply straight across, times 12x plus 5 over 8x minus 1. Looks like that is it. That's all you can do. That is your answer. You may have a time when they want you to distribute. Probably not. You could use it like, leave it like this, and that would be a good answer. Okay? Perfect. All right, let's move on again. All right. Before I would try to find this common factor, I would go ahead and simplify that. I would kind of break it up. I'd make it like a factor first. So this is what I would do. I would make it my common denominator, of course this is over 1, would be 4 and then u minus 5. I would make it like that. Okay, 4 and then u minus 5. Then mine, of course, that's the denominator. And then this one, of course, it's the same exact thing, 4 and then u minus 5. Okay, that's exactly the same thing. I just factored it. So this top part, u minus 8, doesn't change. It stays the same. It didn't change. But here it was 1. Now it's 4 u minus 5. This becomes 4 and then u minus 5 because it's 1 there. Okay, so I added that. So now at the bottom on this situation, this is actually 1. So u minus 5 is the common denominator there, plus, and this is the u minus 5 here. That's the common denominator there. You see how this is the same. It doesn't change the top, but this was 1. And that this is 2, what was added is u minus 5. Okay? So now that you have the common denominator there, 4 and then u minus 5 here, let's combine those. This becomes 4u minus 20. And then, of course, don't forget, if it's a negative in between, you have to do the distributing of the negative. This becomes negative u plus 8. Okay? All over, u minus 5 is at the bottom here. And then at the top, of course, distribute 2u minus 10 plus 2. Okay? So combining like terms at the top, This becomes now 4u minus 1u is 3u. Negative 20 plus 8 becomes negative 12. All over 4 times u minus 5. Times, why would I make it times? You know you're dividing. I'll just go ahead and flip these to multiply it, okay? This now becomes u minus 5 over, I can combine like terms, tu minus 8, okay? So you see how I did like a couple steps together. I combined these like terms, 10, 9, 8, negative 8, and then I flipped them as well. All right. So I can bring out my, I know I'm going to cancel those out, but I can bring out my, this now becomes 3 times u minus 4. Okay. This becomes 2 and u minus 4 as well. Okay. So I know I can cancel this out. These out. I can cancel these 2 out. And that's it, it looks like. So at the top, what's left over is 3. 3's at the top. And then at the bottom, what's left over, it looks like just 4 and 2, which is 8. 3 over 8 is what's left over there. Yes, a lot of work, but we have to be able to do that stuff. And it just takes time. It's time consuming, and that's what will cause a lot of mistakes. So make sure you're taking your time, okay? All right, let's do the top here. What is our common factor? As you see, with the 4 and the 49 and 7, it's 49 is 7 times 7, so a 7 is common, but then they have an extra 7. For 49x is your common factor there, 49x, okay? What was added there was an x, so we have to add an x at the top, 5x. What was added to 7x to get you 49x? 7. We multiply 7, we have to multiply 7 on top, 35. Okay. Same denominator there, looks like 49x. Okay, 49x. So what was added here was multiplying by x. X squared. Oof. Okay, and then you have to multiply, in order to get there, you'll have 49. Okay, and this becomes minus 49. So now that you have the common denominator here, okay, this can become 5x minus 35 over 49x. This now can become x squared minus 49 over 49x. Okay. We can actually bring this down. 5 parentheses x minus 7. How do we know? Okay, we found the greatest common factor between those is 5 over 49 times now, because it's divided here, times the reciprocal, which is 49x. Sorry, this is x. 49x over x. What is this? Perfect square with a minus in between. Difference of squares. X minus 7, x plus 7. Okay, looks like the x minus 7 is going to cancel out. 49x's are going to cancel out. Okay, what is left over? 5 over x plus 7. Okay, exclusion is x cannot be negative 7 there. X cannot be negative 7 because it can't make it 0. That's our answer. All right. All right, let's do it again. Do it again. So we have here, if you're seeing here, what is our greatest common LCD? Least common denominator? It looks like v plus 2 and v minus 4. Okay, that is it. V plus 2, v minus 4. And what happened here is you have a 5, but what was added was what? V minus 4. So it's going to be v minus 4 there. And then here we have a v minus 4 already. What was added was v plus 2. 1 times v plus 2 is just v plus 2. Okay. Same situation is going to go on the bottom here. Looks like v minus 4 or v plus 2 and v minus 4. and then V plus 2, V minus 4. What was added was V plus 2, so this is going to be 2 times V plus 2. What was added here is V minus 4, so this is 4 times V minus 4, okay? Now, what you're going to do is combine like terms up here. So this becomes 5B plus minus, sorry, because you're distributing here, minus 20. And then this is plus B plus 2, okay, because it's just stayed the same. Over, what is that? B plus 2 and B minus 4. And then, of course, you're dividing by these two come together. This now becomes 2V plus 4 plus 4V minus 16, all over the same. V plus 2, V minus 4. I'm going to combine like terms here. I'll have B, 5V plus 1V is 6V. And then negative 20 plus 2 is negative 18 over, of course, V plus 2, V minus 4, times, if I change that division to times, you know you have to take the reciprocal, V plus 2, V minus 4, and I can combine these like terms, 2V plus 4V is 6V. And then negative 16 and positive 4, it looks like it's going to be negative 12. Okay. I'm going to, greatest common factor there is 6, so this will be B minus 3, it looks like. And it looks like here the greatest common factor is 6, but it becomes B minus 2. Okay. So the 6's cancel out there, but the binomials do not. 6 plus 2, V plus 2, V minus 4, V minus 4 cancels out. V minus 3 is left over here, and it looks like over V minus 2 is left over. This is your answer. You cannot cancel out the V's. Do not do that. Okay. There you go. That, you thought that was difficult. Wait till you get to these exponents down here. But we are almost through. We are basically a couple pages. We're 4 pages in. We only have 2 left over. This is the last page front and back. Okay. All right. So this problem that is here is the same exact type of problem that we just did. So what you're going to have is your great LCD here is going to be what? W plus 9 and then W minus 3 minus, then it will be W plus 9, same thing, W plus 9, W minus 3 there. Sorry, a little hole. And what is common is, what's already there is W plus 9, W minus 3 isn't there, so we're going to have to add that to the top, W minus 3. Okay. Here, W minus 3 is already there, W plus 9 isn't, so we're going to have to add that to the top. And of course, if you want to put the 1, it's fine, because you're going to have to distribute the negative. All right, bottom, same common denominator, it's W plus 9 and W minus 3. Is that common denominator for both? We already have a W plus 9. We added the W minus 3. So up here at the top, we have to add the W minus 3. Same situation there with the 2. W minus 3 is already there. We have to add the W plus 9 at the top. Okay. So now combine like terms. Not combine like terms. Now we can combine them because they have the same denominator. So this becomes 5W, because I'm distributing, minus 15. And don't forget to distribute the negative 1 to both. So this becomes negative W minus 9. Okay. Over, of course, the W plus 9, W plus 3. W minus 3. Y'all let me do it. Y'all let me do the W plus 3. W minus 3. Okay, over Same thing, distribute. This becomes W plus 2W minus 6. Distribute there. This is plus 2W plus 18, all over the same denominator, which is W plus 9, W minus 3. Okay, I'm going to combine like terms over here. So my like terms, I can bring it down here. My like term here is 5W minus 1W is 4W. 4W, negative 15 and negative 9. Okay, negative 15 minus 9 basically is negative 24. Minus 24 over that denominator times, instead of dividing, I'm multiplying by the reciprocal. W plus 9, W minus 3, and then putting this part at the bottom, combine like terms, 2W plus 2W is 4W. And then 18 minus 6 is positive 12. Okay. I am going to take the greatest common factor with 4's out, W minus 6 there. Take the greatest common factor 4 out, W plus 3. Okay. And then I'm going to, I see the 4's cancel out there, W minus 9, W minus 3, I mean W plus 9, W minus 3's. What's left over is W minus 6 over W plus 3. Okay. And that is your answer. Those W's do not cancel out. Okay. Good. So we have that. We've done 2 of those problems that are long. This one, believe it or not, is almost, it could be a little bit more difficult depending on you and depending on how much work you are putting in and how much you are recognizing things. Okay, because these two, this is x squared minus y. It's not multiplied. This is subtracted. So there's a difference there. Same thing here. This is added. That's added. So we're going to do the stars. This one you do the same way you do over here. What you're going to do here, those have a negative exponent. Write your answer as using only positive exponents. So this is actually rewritten as this. 1 over u squared plus 1 over b squared. Okay? Because why? It has a negative exponent, it has to go to the bottom of a fraction. Negative exponent has to go to the bottom of a fraction. And that's what I did there. Okay? So now we'd have to have, up here it's just a regular 1. We're okay with that. But down here, we'd have to have a common denominator. What is our common denominator here? U squared, b squared. So our common denominator is u squared plus b squared. I mean, times. What am I talking about? U squared, b squared plus, of course, u squared, b squared. Okay. What did I add here to get this? A b squared. So at the top, it has to have a b squared added. What did I add here to get here? A u squared. So I have to have a u squared up there. Okay. So now that these are common, I can put the tops together. So it's going to be 1 over b squared plus u squared over u squared b squared. Okay. Now I can multiply this by the reciprocal u squared v squared over v squared plus u squared. Okay. So I flipped this. This is up top. That's at the bottom. And I'm multiplying anything by 1 is just itself. Multiplying anything by 1 is itself. So this is your answer. U squared, v squared over b squared plus u squared. And all the exponents are positive. That is your answer. Okay. All right. Let's get that one. And I'm going to put this one on a separate sheet of paper so I can have as much room as I need. So 1 over b to the negative 1 plus a squared is my problem. Okay. So what I'm going to do, of course, is change that b to negative 1 to this. Okay. B to the positive 1 at the bottom plus a squared. Of course, it's over 1 because I need to find a common denominator. And if you can kind of see it, it's b. So b is the common denominator. Did I change that? No, it's 1, because that's 1. So here, from 1, it became b, so I basically multiplied it by b. I have to multiply the top by b. That becomes a squared times b. Okay, now that they have a common denominator, I can put them together. This is going to be 1 plus a squared b over b. Okay, so now, of course, I'm going to multiply by the reciprocal b over 1 plus a squared b. And 1 times anything is itself. Your answer is going to be b over 1 plus a squared b. This is your answer. Okay? And again, it's just about getting that basic understanding of everything. And once you get it, I know that you can do this. So let's go ahead and try this one. So we got the answer here as b over 1 plus a squared b. We got that answer for the second one. We kind of didn't have any room to do it. Let's try this one. So again, a plus b squared over, of course, we're going to flip this and bring it down at the bottom of a fraction, a squared plus 1 over b squared. Okay. What is that common denominator? A squared b squared. Okay. Hold on. Sorry, I didn't give myself enough room. A squared b squared is the common denominator. And then, of course, this is a squared b squared. What happens to the top? I added a b squared, so I have to add a b squared up top. Same thing there. I added an a squared. I have to add an a squared up top. So now they have the common denominators. You can combine them. So a plus b squared is there over, when I combine that, this becomes b squared plus a squared, okay, over a squared b squared equals, now that I have this a plus b squared, I can multiply by the reciprocal, which is a squared, a squared b squared over, remember that's over 1, b squared plus a squared. Okay. And it doesn't look like anything cancels out to me. So what I would do is when you multiply, just put them next to each other. You have a squared b squared times a plus b squared all over b squared plus a squared. I think that is your answer. Okay, I'm going to check it real quick, but I believe that that is just your answer. Let me check that. Answer, that's how you would solve it. And that's how you get the, that's the answer there. You can't like get rid of those two. And that's what I kind of thought. I felt like you would be able to, but you can't. All right, so this one also, you do not want any negative exponents for this. So this one looks crazy, really, once you start to get it. So this is going to be 5 over y, because this y to the 1 comes down, over 1 over x squared, because again, that comes to the bottom of a fraction, minus 1 over y to the 1, because that goes to the bottom. So this is what this problem really kind of looks like. Okay, the top is set though, and the bottom we have to combine like terms to get the LCD to combine like terms or combine terms. So this LCD is x squared y. Okay. And the top 5y is by itself, so we're okay with that. So now, what did you add? You added a y, so at the top you're going to add a y. What did you add here? You added a x squared at the bottom, because it already had a y, you added an x squared, it has an x squared there. So now they have the like terms, you can combine them. 5 over y, divided by, of course, y minus x squared over x squared y, because I combined the term. like terms, and then you can put those together. Now we can write it out. 5y times x squared y over y minus x squared. Look at these y's can cancel each other out. So your answer here looks like it's going to be 5x squared over y minus x squared. That is it. Why can't you like cancel those x squares out? Because this one has a minus in between. That means they're married to each other. You can't just get rid of one of them. Nope. We leave it that way. Okay? Good. All right. So for this one, what you're going to do is with all of these type of problems, all you're going to do when you see it looking like this is you're just going to get rid of all the denominators by multiplying all of the fractions by the common denominator. So what do I mean? I'm going to take this whole problem and find a common denominator between 2, 6, and 3. Okay, since they're all multiples of 6, the bigger number, I'm going to use 6. I'm going to multiply 6 by everything, and you'll see what it does in a minute. So 6 multiplied by this, so 6 times v over 2 minus 6 times 1 over 6 equals 6 times v over 3. Okay, so I took all these separate fractions and multiplied them by 6. The number I chose is my greatest, the factor, okay, that is the bigger factor. All of these is the same factor. So now these two cancel out. This becomes 3. So now this is just 3b. These two kind of cancel out. That's -1 is left over. Equals to, this cancels out with that. That becomes 2b. As you can see, we have no more fractions. And that's kind of what I wanted. Okay, get the v's on the same side. I'm going to subtract 2v here, add 1, subtract 2v. So this becomes 3v minus 2v is 1v is equal to 1. V is 1. That is your answer there. Okay. So getting rid of the fraction kind of pays off. So here, what is my greatest, my common situation, or great LCD, would be the least common denominator in this situation? 12, okay, 3 times 4, 12. So I'm going to multiply every single number term by 12. So 12 times x over 3 plus 12 times 2 equals 12 times x over 4, okay? This now becomes 4, so 4x. 12 times 2 is 24. And then this cancels out, that becomes 3. This is 3x, okay? So now I can combine, I can subtract 3x, subtract 24. And this becomes 4x minus 3x is 1x. And that's equal to -24. That's your answer there. Okay. Same situation here. We're going to find that least common denominator and then multiply everything by it. So it looks like it's 2 and 3. So those are 2. 2 and 3, 6. 6 is the LCD for that. 6. So it'll be 6 times this minus 6 times this equals 6 times this. Okay, looks like that cancels out to be 3y, 3 times 1 times y, which is 3y. 6 and 3 cancel out to be 2. 2 times 1 is 2. And then 6 and 2 cancel out to be 3. And 3 times -3 is -9. Okay. Add 2 to both sides here. This becomes 3y equals -7 divided by 3. You do not have to have a pretty number. So y equals -7 over 3. That's fine. Okay. Good. Perfect. So I think I am right. We are done. That was it. Woohoo! That is Unit 7, Day 5.